In the second case, this noise is present once again, but now we are connecting the output with the input, and this RS is present now with a finite value. Output is connected to compare with the input RS via this feedback path having feedback path gain H. Now the closed loop transfer function due to noise signal alone, previously it was open loop transfer function, now it is closed loop is connected. So closed loop transfer function Cs by Ns is equal to G by 1 plus GH GB H. That means GA GB H. So this is C by N is equal to G by 1 plus GA GB and H. This is GB. So now since it is a closed loop transfer function, we know by general formula or the general derivation that it is G by 1 plus GH. So for G, since noise is acting alone, so this noise will go inside this GB. So for the noise signal, the forward path gain is only GB. So it is GB C by N, GB divided by 1 plus forward path gain and the rest of the feedback path gain. That is, feedback path gain means it is H and then GA and through into towards this. So it is GA into H along with GB. So 1 plus GA GB into H. So therefore, when the noise signal is present alone and we connect the feedback and convert the previous diagram into this diagram, a closed loop system over and above the open loop system, what we are getting? We are getting the overall transfer function from GB. It is becoming 1 plus GA GB H. So it is reduced. So therefore, the use of feedback will be affecting the impact of noise on the overall transfer function of the system. Thereby, it is trying to reduce the effect of noise on the overall response or the overall transfer function of the system. So in the closed loop control system, if we compare with its open loop, the gain due to noise signal is decreased by a factor 1 plus GA GB H, provided it is greater than 1. If this GA GB H is greater than 1, that means this is GA GB H is less than 0. So C by N is increased. So therefore, we can say if it is greater than 1, that means C by N, sorry, not increased, it is decreased actually. C by N is decreased. That means the overall gain of the whole system due to noise signal is reduced if GA/GBH is greater than 1 plus GA/GBH is greater than 1 or GA/GBH is less than 0. So therefore, we can conclude from here that the noise signal which is disturbing the whole process, but by way of connecting through a feedback, we are able to reduce the effect of noise on the system. Now there are other feedback effects. Feedback also has some other effects on the performance of the control system, such as bandwidth, impedance, transient response, frequency response, etc. It increases the accuracy, which we have already understood that more the feedback is used, more will be output or the response will be coming closer to the desired objective, and the error computation will be easier, and the error will be easier. Error computation will be easier, and it will be easier to remove, be removed from the system, and thereby it will ensure more accuracy into the system. It increases the bandwidth and stabilizes the unstable system. Some of the betterment of the improvement of the system, and linearizing effect in graphical analysis of a system can also be observed. While we will be doing some graphical analysis of the control system in some later classes, we will see that the feedback effects will be having some linearizing formats, some linearizing forms. So therefore, we can say that these are the different feedback effects other than those of effects on gain, on stability, on sensitivity, external disturbance, noise, etc. Now, these are some of the applications of effects of feedback in control system. Manufacturing process, manufacturing and production processes, building and home automation, transportation systems, power generation and distribution, medical equipment, agricultural and farming, military and defense systems, robotics, etc. These are very up-to-date and primary important applications of effects of feedback in control system. If we go into any of these applications, we will usually observe what are the effects and benefits, pros and cons of using feedback in a control system. So that's all. I hope you have enjoyed this video. That's all from today's class. We will once again meet in my next lecture. Thank you for viewing.